Welcome, Calculus AB. This is 3.3, increasing and decreasing functions and the first derivative test. The essential question is, what is the use of the first derivative test? Let's begin. So talk about first thing what increasing and decreasing means. I think you know this, but just don't write this down. So increasing is when you go from one point on x1, let's call it right here, and then another point on x2 right here. If you go from the left to right, you're going up. You are increasing. And that's all this says. And if you weren't doing that, let's say you started x1 up higher and x2 is lower from left to right and you're going down, that means decreasing. All right? I'm sure you know this. So this is a better picture I think represents this. So I have a function right here that's starting from the left, we're decreasing. And then from these points, x equals a to x equals b, it's constant, it's not changing. And then after x equals b, we are back to increasing. And there's a relation of the derivatives of this. And we've done this, you probably have seen this already, where the f prime of x is less than 0 when we're decreasing. It is 0 when we're constant, we're not changing, our slope's not changing. And it's positive when we're increasing. So this is theorem 3.5 in the book. So you have to know this for this chapter. Again, if the derivative is negative, the function's decreasing. If it's 0, it stays the same. And if it's positive, it's increasing. So we're going to use that to figure out when a function is increasing on an interval. So let's say you're on some interval a to b. The way you figure out where the function is increasing and decreasing is you first have to find the critical numbers, and we've discussed those strategies last chapter. And then we use those to determine our test intervals. You want to test between every critical number. And then you want to determine the sign of f prime of x by using a test value. And then you're going to use theorem 3.5, basically that last page, and that says the derivative is positive or negative, to determine where increasing or decreasing. So for example, if your critical numbers were at 0, 3, and 5, okay, so these are your test cases. So you might even your test cases are going to be from 0 to 3, and 3 to 5, and then 5 to like infinity, or 5 and beyond. And you're also going to have the test case from negative infinity to 0. So we're going to want to do, if these are our x values here, we're going to want to pick some value in between. So like 0 to negative, I could do like x equals negative 1 would be a test value. 0 to 3, I want to find a test value, maybe x equals 1. And here maybe x equals 4, and maybe here x equals 6. So you'll find test values in each of these and figure out which areas it's increasing and decreasing. All right, you only need one test value. So, and another note here, it doesn't have to be between a strict interval a, b, it can be just everything, negative to positive infinity, or maybe we put an end on one side but not the other. So let's do an example here. I want to find the open intervals in which f of x equals x cubed minus 3/2 x squared is increasing or decreasing. So first thing I got to do is I got to find the critical numbers. So if you want to find the critical numbers here, I don't have endpoints, it's not a closed interval. So I just have to find using the derivatives, where the derivative is 0 or does not exist. So my f prime of x is going to be 3x squared minus 3/2 times 2x, and the 3 and the 2's are going to cancel out here, so it's going to be 3x squared minus 3x. Now, I want to factor that out. That'll help me see the derivative. So I factor out a 3x, and I'm left with x minus 1 equals f prime of x. So our critical numbers are going to happen when f prime of x equals 0. It's never going to be does not exist. So 0 equals 3x times x minus 1. So critical numbers are going to be x equals 1. So x equals 1 and x equals 0. There's my critical numbers. That's the first part. So this is going to tell me what my intervals are. Now, I kind of want to make a chart for this. So I'm going to make an interval chart. I'm going to do it this way. Move it down a little bit. So I have a few intervals. Since I have two critical numbers, I'm going to put this one's going to be x equals 1, or x equals 0, and x equals 1. So my intervals, I'm going to call this interval here, this is going to be from, I'm going to label this, I like using this notation, negative infinity to 0, and this interval is going to be from 0 to 1. Notice it's curved, so that means it doesn't include those. And this interval is going to be from 1 to positive infinity. So I do my intervals. Now you want to try some test case. So I'm going to try a test case right here in each of these. Now I'm going to do I'm going to do f prime of some number in this range. I'll go -1 right here. And let's do some number in this range. So we can go, let's say if I went f prime of, I don't know, let's do 1/2. It's in the middle. So f prime of 1/2. And then we're over here, let's do f prime of 2. That's easier. So if I plugged in f prime of -1, I know my f prime is 3x squared minus 3x. So it's going to be 3 -1 squared minus 3 times -1, which will be 3 plus 3, which is 6. Okay? For this interval, if you plug in 1/2, you get 3 times 1/2 squared minus 3 times 1/2. So 1/2 squared is 1/4, so it'll be 3/4 minus 3/2, not fourths, 3/4. Ooh, 3/4 minus 3/2. And 3/2 is the same thing if you multiply by 2/2. That's going to be the same thing as 6/4. So 3/4 minus 6/4 is going to be -3/4. All right, now if you plug in 2. So if I plug in 2, I'm going to get 3 times 2 squared minus 3 times 2. So 2 squared is 4, 3 times 2 is 12, minus 6, which will be positive 6. So as you can see, using that one figure here, I have a positive derivative, so this is going to be increasing on this interval. Since this is negative, we're going to be decreasing. And since this is positive, we are going to be increasing. So for that problem, I just wanted to figure out where we're increasing and decreasing. So this interval for increasing, in this interval for increasing, and this one for decreasing. Now let's show a picture of what that graph looks like. So your critical numbers were at 0 and 1. And notice here we're increasing. The graph is going up from the left till we get to 0. Then we're going back down. And then we're going back up again. So that matches the graph of that function. Now we have some functions called strictly monotonic, always increasing or decreasing. So in this case of x cubed, at this point it's always going to be increasing. Just when it gets to 0, it doesn't increase a lot, but as it gets out in both directions, it increases more. So this will always be increasing or decreasing, even though there's a critical number right here at x equals 0. So it doesn't always necessarily turn. So what we can use intervals for, of increasing and decreasing, can help us find these relative extremum. Notice that we had a relative extremum at x equals 0 and a minimum at x equals 1. So we can use that first derivative in the test to kind of figure out what's a maximum minimum without having to plug in a bunch of different numbers. And here's a chart that kind of explains this. So from going from left to right, if you are increasing, and this C is your critical number right here, if you are increasing from the left side and increasing from the right, you have relative minimum. It's kind of like going down and then coming back up, you have a minimum. If you start increasing from the left and then decrease afterwards, you'll have a relative maximum because you're going up and then coming back down. That's relative max. Now, if they match, like if it's increasing on both sides or decreasing on both sides, then it's neither a minimum nor a maximum. It's what we talked about in that last slide. So let's find the relative extremum of this function on this interval 0 to 2 pi. So same thing we did before. We don't have endpoints here, but because those aren't square brackets. But let's find critical numbers. So I have to find my f prime of x, which will equal 1/2 plus cosine of x. Nope, it's not plus cosine. It's 1/2 minus cosine of x. All right, so that's going to happen. Now, as this will never, it's not dividing by 0, so we'll never say does not exist. It's f prime of x equals 0. So 0 equals 1/2 minus cosine of x. And if you add cosine of x to each side, you get cosine of x equals 1/2. So what areas from 0 to 2 pi is the unit circle? Well, cosine equals 1/2, and cosine is your x values. This is going to happen when x equals pi over 3 and 5 pi over 3. All right, now that we know those, I can make my chart again. And I think this chart just kind of helps organize the information. So every vertical line, this will be I'm going to write x equals pi over 3 and x equals 5 pi over 3. Those are critical numbers. So we have intervals. Now it's 0 to 2 pi. So this interval here is going to be from 0 to pi over 3. This interval is going to be from pi over 3 to 5 pi over 3. And this interval is from 5 pi over 3 to 2 pi. All right, so now I want to pick some numbers. And I can pick any test values I want, but since we're talking about let's pick something on the unit circle, that would make sense. So one I can take for a test value right here, I can take f prime of, I'm going to take pi over 4. And for this one, I'm going to take pi, because pi is an easier number for me to find. And for this value, let's just match with this pi over 4. We're going to say f prime of 7 pi over 4. Okay, so these are my test values. Now I'm going to plug those in to the derivative and see what I get, see if it's positive or negative. If you're plugging in pi over 4 here, you get 1/2 minus cosine of pi over 4. So cosine of pi over 4, what's that? Cosine of pi over 4 is going to be square root of 2 over 2. Okay, and what is that going to be? Well, 1 minus square root of 2 over 2. Square root of 2 is bigger, or square root of 2 is bigger than 1. So I know that number right there. It doesn't really simplify. It's 1 minus square root of 2 over 2. It doesn't simplify, but I know this number is negative, so I know this is going to be negative. Okay, that has to be a negative number. Plug it into the calculator to verify. Now for this one, it'll be 1/2 times cosine of pi. Cosine of pi is the x value, so minus -1. So this becomes 3/2. So this is positive. And if 7 pi over 4, 7 pi over 4 is going to like right here on the unit circle, and that's your x values, it's going to be positive square root of 2 over 2. So 1/2 minus square root of 2 over 2. And same reason as over here on the left side, this will be negative. So the relative extremum of the function, since we're going from negative to positive to negative right here at those extremum. Since in this, so at x equals pi over 3, what I can say is that when x equals pi over 3, since I'm going from negative to positive, so it's going down to up, I'm going to call this is going to be a relative minimum. And from going from positive to negative, x equals 5 pi over 3 is going to be a relative maximum. So you have to do those charts to figure that out, and there you go. Now let's look at a graph of this. So here's a graph to prove this. From 0 to 2 pi, I have a relative minimum right here, and a relative maximum here at 5 pi over 3. And there you go, all done.